Let's practice finding the equation of a perpendicular bisector together. It looks like that in this problem we are going to have a segment of xy, and it's going to be formed by the points of x, which is at -9, -7 in quadrant 3, and y, which is -3, 5 in quadrant 2. And while you totally don't have to do this, I'm going to go ahead and put this on a coordinate plane so you can visualize what's going on. So here we have a coordinate plane. We know point x is going to be down here in quadrant 3, and point y is going to be over here in quadrant 2. We're told that xy is a segment, so we can go ahead and draw that. And we're supposed to be finding the equation of line J, which is supposed to be a perpendicular bisector for segment xy. Let's start by finding the midpoint of segment xy so we know where the perpendicular bisector is going to cross through segment xy. So to find the midpoint of xy, let's go ahead and average the x values. So take the -9 plus this -3. Those are the two x values for xy. Go ahead and divide that by 2. That's going to be the average of the x's. Let's go ahead and average the y. So take the y value of -7. Let's go ahead and add 5 and then divide that by 2. This -9 plus -3 is -12. Divided by this 2 is going to be -6. So the midpoint is going to be -6, comma, and then this -7 plus 5 is going to be -2. -2 divided by the 2 on bottom is going to be a -1. So this midpoint of -6, -1 is going to be right over here in quadrant 3, and that's where the perpendicular bisector is going to intersect segment xy. Basically, this is the point where line J is going to go through segment xy. Now to figure out the equation for line J, we need to figure out the slope of it, but the slope of it is going to be related to the slope of segment xy. If we go ahead and find out the slope of segment xy, then we can find out the slope of line J. So it's important to know how the slopes of perpendicular lines work. If we know the slope of xy, that's going to be the opposite reciprocal slope of line J. Alright, so let's go ahead and find out the slope of segment xy. We can do rise over run here, or we can do this y2 minus the y1 over the x2 minus the x1. So if we go ahead and write that in, we're going to have 5 minus -7 over this -3 minus this -9. If we go ahead and simplify this a bit, we have this 5 plus the 7 on top, so that's really going to be a 12. And then on the bottom we have this -3 plus 9, that's really just going to be 6. So 12 over 6 just simplifies down to being a slope of 2. That being said, if we know the slope of segment xy is going to be 2, then we know the slope for line J is going to be the opposite reciprocal, so the opposite of 2 is -2, and the reciprocal of -2 is going to be -1 over 2. So while 2 is the slope of segment xy, -1/2 is going to be the slope of line J, or the perpendicular bisector. At this point, we have everything we need to go ahead and find the equation for line J, so let's go ahead and put some pieces together. We know line J has to go through this midpoint of -6, -1 because it needs to be a bisector. And we also know the slope of line J has to be -1/2, otherwise it won't be perpendicular to segment xy. Given that we have a point and a slope here, let's go ahead and use point-slope form to write an equation. Alright, so remember this is point-slope form, where m is the slope, and x1 and y1 just represent coordinates of a point that we have. So let's go ahead and plug in this -1 in for y1, this -1/2 in for m, and the -6 in for x1. Alright, so this is our equation. We've plugged in that point and slope. Cleaning this up a little bit, on the left side we just have y plus 1, and on the right side, if we go ahead and clean this up a little bit as well, we have this -1/2 multiplied by the quantity of this x plus 6. This right here would be our equation of line J in point-slope form. So while this is our equation in point-slope form, we also want to write this in slope-intercept form. We can do that by just starting by distributing this -1/2. So leave the left side alone, it's just going to be y plus 1. Distributing that -1/2, we're going to have -1/2 x, and then -1/2 times 6 is going to be a -3. Finally, let's go ahead and take away 1 from both sides of the equation. If we go ahead and do that, we're going to get y is equal to -1/2 x, and then -3 take away 1 is going to be -4. This would be the linear equation for line J in slope-intercept form. Now, while we have both of our equations for line J in both forms, let's go ahead and just see if we can graph this to see if it makes sense. Typically, using slope-intercept form is going to be a little bit easier to graph from, so let's go ahead and use that one. So we know the y-intercept is going to be -4, and the slope is -1/2. So if we go ahead and take a look at that, let's see our graph over here. Let's see, we have -4 as our y-intercept, so let's make sure we plot a point at -4 on the y-intercept, that's right there. And then we have a slope of -1/2, so that means we can go down 1 and to the right 2, down 1 to the right 2, down 1 to the right 2, or we could go up 1 and to the left 2, up 1 to the left 2, and look at that, it's going to intersect with our midpoint. And if we go ahead and draw a straight line through each of these points or these coordinates, we can see that we do have line J, which looks like it is a perpendicular bisector to segment XY, where this segment from X to the midpoint and the midpoint to Y are congruent to each other, and we also see that they intersect at a perfect 90-degree angle. And just like that, hopefully we simplified down the process a little bit of finding the equation of a perpendicular bisector to a given segment. If you found the video helpful, please consider giving it a thumbs up and letting me know in the comment section down below, and feel free to share this video with a classmate or friend who might also find it helpful. As always, keep up the great work that you're already doing, and I'll see you in the next one.